Welcome to Unit 5, Lesson 11, Evaluating Logarithmic Expressions. Let's find some logs. Okay, so now here, when you see log written like this, what this means is log base 10. So on your calculator, next to the 7 button is the log button. The log button on your calculator is base 10. You don't have to do anything. So basically, is log base 10 because there's no number written right here. And scientists and mathematicians know that when there's no number, it's base 10. So basically, if it's a 1 as the first number, all you have to do is count the zeros. And these all have as 1 as the first number. So 10. How many zeros in 10? 1. How many zeros in 10,000? 4. Now, 0.1 is equal to 1/10. And we know from our exponent laws that 1/10 is equal to 10 to the negative 1. And what logs do is count the exponents. So the log is negative 1. 1,000, that's 3 zeros, but it's in the bottom, so it's negative 3. Okay, so let's look at this. Finding logs on a calculator. So Tyler rearranges the exponential form into logarithmic form, which is what you have to do when you don't know the exponents. You have to transform it. So he hits the log button on the calculator, which is next to the 7, which is base 10. So the base is already 10, and writes down an approximation of 1.279. So when you are dealing with exponents and they're not perfect numbers, which means it's not a whole number as an exponent, the number is going to be irrational, which means it goes on forever without repeating or stopping. So we have somebody else wrote down a different number. And what are the difference between these two numbers? What Tyler did was round to the third digit. That's what he did. He rounded to the third digit. So that's called the thousandth place. Thousandths, THS. He looked at the number to the right. It was 5 or more, and so that 8 pushed to 9. What the other person did, Priya did, was she rounded to the 1, 2, 3, 4, 5, the fifth place, which is 100,000ths. So we don't know what the number after the 5 was. This could be 745 or bigger, or it could be 750 to 4. We don't know. So we got to remember our rounding rules. Now, what I'm going to tell you to do, if nobody tells you where to round to 4 digits after the decimal. And so what you're going to do is go 1, 2, 3, 4. This is the number that you round. If this number is 0 to 4, add 0. If it's 5 to 9, add 1 to the number to the left. So you look at the number in the box. You look at the number right here in this circle, and then you either add 0 to the number in the box or add 1 to the number in the box. That's rounding. So hit the log button on your calculator and you download it, Calculate 84, type 19, hit enter, and you'll see a string of numbers. And B, why might log 19 be discussed in different ways? Because it is an approximation. Because the answer is actually irrational and it goes on forever and we have to round it to approximate it. Now, what Priya could do is put her value into the calculator and she will get close to 19. She won't get 19, but she'll get very, very close to 19. And the more digits you go out, the closer you will get to 19. Okay, express the solution to each equation using a logarithm. That means we must transform it first. So we have to write this as log And I'm not going to write base 10. And then we're going to push these buttons on the calculator. Now, basically, when you go from exponential form to logarithmic form, the answer and the exponent switch because logarithms count exponents. And so we're going to find the value of m using the calculator. You're just going to look on your calculator next to the 7 button, hit log 24. That's going to give us to 4 decimal places, 1.3802, because the number next to the 2 is a 1. And then log 750 gives us 2.87506. The number next to the 0 is a 6, so this becomes 1. Again, just hit the log next to the 7 button on your calculator, 1.95424, so that stays 2. Log 1005 is 3.00216, so this becomes 2. And then log 9 becomes 0.95424, so that stays 2. So there we go. And you notice log 90 and log 9 had the same decimal approximation.